As introduced by our instructor, a difference of squares can be factored by applying the formula stated below. A squared minus b squared is equivalent to the product of a plus b and a minus b. Or else it is equivalent to the product of a minus b and a plus b. We simply need to identify if the expression consists of two squares that are being subtracted. Let us consider the following example. 4x squared minus 81. By looking at the above expression, it can be seen that 4x squared is a square of 2x, and that 81 is a square of 9. Now we can rewrite the initial expression as follows. A square of 2x minus 9 squared. Applying the difference of squares formula, the factor of the expression is the product of 2x plus 9, and 2x minus 9. This cannot be factored further.
This is how we identify if an expression is a perfect square trinomial. If the first and third terms are squares, figure out what they're squares of. Multiply those things, and then multiply that product by 2. We then compare the result with the original quadratic's middle term. If it's a match, then we've got a perfect square trinomial.
Let's consider the example. A square of x plus 10x plus 25. Well, the first term, x squared, is the square of x. The third term, 25, is the square of 5. Multiplying these two, we get 5x. Multiplying this expression by 2, we get 10x. This matches our middle term, hence we have a perfect square trinomial. But what was the original binomial that they'd squared? I know that the first term in the original binomial will be the first square root I found, which was x. The second term will be the second square root I found, which was 5. Looking back at the original quadratic, I see that the sign on the middle term was a plus. This means that I'll have a plus sign between the x and the 5. Therefore the factored form of the above perfect square trinomial is a square of x plus 5.